My name is Dan Clark, and I work for Pragmatic Works. I don't know if any of you have heard of it. How many have heard of this side? Yeah, I'm from the States, if you can't tell. Pragmatic Works, we do a lot of BI work. I've been doing a lot of BI work with Microsoft and being one of their preferred partners. And a lot of guys that work as consultants write books and that kind of thing. So it's a pretty good group to be involved with. Haven't gotten across the pond yet, so most of our stuff is in the States. I'm from Pennsylvania. Does anybody know where Pennsylvania is? So if you know where Philadelphia is, I'm about an hour west of it, so Philly guy. And I've been coming over for a while now, so this is what I'm probably on my 8th time over here or something like that. And I love it over here, so I like the people, I like to come over, walk around the old, when we're talking about old, we talk about 200 years. That's nothing over here. So. But anyhow, let's get talking about Hadoop. What we're going to do is talk about the Mapreduce jobs in C# and talk about some other stuff too. A question I like to do is, what's your background in the Hadoop space? How many of you have never cracked open Hadoop yet? That's wonderful. Now I can tell you anything. You guys believe me until next week. Dan lied to us. What the heck's going on here? So anyhow, unfortunately, this is going to be a little bit more theoretical than I had hoped, because my Hdinsight emulator blew up about 20 minutes ago. So I'm going to show you the code, walk through the code, and I will release the code for you guys to look at. I don't think it's with the packet yet, but so if you guys want to try these things out, then go ahead and you can say, "Hey Dan, I got to work, you big dummy." So we'll see how it goes. And the other thing is, so with a lot of you, I'm going to review over just about the space too, not just the C# part of it, because the C# part of it is probably the smallest part. So if anybody has their cell phone on and it's not on silence, it's playing God Save the Queen or something real loud, turn that down a little bit. Although it takes a lot to get me in here too. So, and the other thing is, if you have a question, go ahead and ask. Okay, so I like to do things a little bit more informal. I want to look at Hadoop and Hdinsight overview there. A little bit about the Mapreduce processing, because what it is that's the whole kit caboodle really is. That's how it handles large amounts of data, is through this Mapreduce. So how can we create a Mapreduce? Well, there's a couple different ways you can create a Mapreduce. We'll see that one way. If you want to go natively, you can go into Java and write Java code to do the Mapreduce, and then that will actually set up and run. But most of it, I don't know how many Java programmers are here. I dabble when I have to. So I have written Mapreduce jobs in Java. How many C# guys are here? Hopefully all of you, right? If you know C#, you know Java. If you know Java, you know C#. It's all the same. Okay, so if you want to work on it in C#, then what we have to do is look at streaming. And so there's a streaming interface that actually streams the data out. You intercept the stream, and then the stream, you do whatever you want to it for the mapping, and then you send it over to reducing, and then it streams the output. So that's basically the first way we're going to look at doing it in C# is with the streaming, and then using the .NET SDK for Hadoop. So right now there is a SDK put out, and it's kind of half-baked right now. So some things work pretty good, some things need a little work on it, and it's open source. So how many of you work with the open source community? So some of the frustrations of the open source community are it's open source, there's not a lot of documentation. You know, it is what it is. Okay, so if you're used to the stringent Microsoft thing, well, I shouldn't, Microsoft stuff blows up too, but at least when it blows up, you know, you can probably find something out about it and do some searches. And where I've done a lot of searches and I say, it works. No, it doesn't. It works. I did exactly. So, and who do you call? I mean, you know, this guy could be, you know, usually they're pretty good, but it's just a whole new ball game as far as that goes. When you're trying to do professional, you know, you have to get it out Friday, and, you know, it's Thursday evening, and you're trying to get help on this thing. It's open source. The .NET SDK, we're going to take a look at that. Creating and running a C# Mapreduce job. And then querying results with link. So as part of that SDK, they do have a thing that will convert from a link to the HQL, the Hive SQL, and then spit your results back. So you can work at it using the language integrated query. So, and again, that in theory it works, but it's one of those things. Okay, so the first thing is when we talk about Hadoop. Okay, so Hadoop is what do you know about Hadoop? Somebody fill me on Hadoop. What's Hadoop? Yeah, so first of all, it's a distributed file system. Why was it, who developed it? It's Apache, okay, so Apache went out and developed this thing. So everything's kind of based off the Apache system. And some of the biggest users are, why did this come about? I mean, what was the emphasis on why we needed that?
So it's large volumes of data.
Yeah, he wanted to do large volumes of data, and basically it started out in what space? Am I not? Search engines, yeah, search engines. So Yahoo, big stuff on Yahoo, you know, those type of places. They actually found out that you know they really didn't have a way of doing searching on this tremendous amount of data, and so they had to try and develop their own system to do it. And through all this research and everything came out this Apache Hadoop and implementation. So one of the things you have there is it's a distributed file system. So it's going to distribute storage using and processing, and really that's actually important there, using commodity hardware. So basically what we're saying is let's just use cheap hardware, a whole bunch of it, and then spread the data across that hardware, and also not only spread the data across the hardware, but what else? Which is the key. The processing, right? So instead of bringing the data to the processor and running it, the processing node, and then spitting the data back, it is actually very costly to move data around. It's a lot easier to move code around. That's small amounts of code, large amounts of data. So that's what they do, distribute code across the system. And then it's a family of open source tools needed to implement. Boy, I'll tell you what, it's a family. So there's a whole bunch of stuff there. One of the things, and so it was originally developed for the Linux environment. And so then there's also a Hortonworks. Has anybody heard of Hortonworks? No? Well, if you start developing in here, you're going to hear of Hortonworks, especially if you're a Windows guy. Hortonworks developed the HTTP for Windows, so it'll actually take it, and you don't have to run it on a Linux server. You can actually run it on a Windows server. Okay. Now, it doesn't really matter to if you're not an administrator to you whether it's running on the Windows or the Linux. Okay, to you it doesn't matter. And really, there's a great tool out there I use for learning a bunch of this stuff is the Hortonworks Sandbox. Okay, unfortunately, if you go out to Hortonworks, you download a VM and set it up, and it's all ready to go. You just kick it on, and then through your Explorer, you go in and you work with it. There's tool sets and everything you can use for that, and that's really nice for learning because there's helpful tool sets for you to work with. On the Microsoft side, and there's not a lot of tooling yet to help you, and IDEs and everything like that. There's no Visual Studio. There's really no Visual Studio add-in for going in there and working with it directly or anything like that. We're back into the days of really command lines and Notepad and all that crap. So, and the other thing is they're really into, for some reason, I don't know, the PowerShell is like nirvana to them, to Microsoft, and all that. So they want you to do all your development in PowerShell now. So, okay. So anyhow, if we come over to the Microsoft side, it's Hdinsight. And Hdinsight is a little bit different because Hdinsight is actually a cloud-based implementation. Okay, so what you're going to do is instead of having this on your local servers, this is, again, Microsoft pushes to bring everything into the cloud. So you set it up in the cloud. How many of you have worked with Windows, Azure, and cloud and services and all that stuff? A few of you. Okay, so there's two ways to do this. You can actually set up a trial service in the cloud, but they're being really, I don't know, pinchy on it because they only give you a month free trial on it, and then they say, well, you got to start paying for it. But I'm a developer, I don't really want to pay for it, you know, that kind of thing. I'm just doing it to look at it. So you can go out there and do that. There's also an emulator. So this is an Hdinsight emulator, which you actually put on your local machine, and it would actually emulate that. And it works pretty good as far as the emulator. All right? Any questions on that? So if I was going to start out in this thing, there's two things I would look at. I would look at going to the Hortonworks Sandbox learning environment, which in my other talk, I'm going to show that exclusively as we go through looking at Hive and that kind of thing. And then I would also come in here and look at your Hdinsight emulator being, you know, a Microsoft area. All right. So here's the Hadoop ecosystem. So what happens is it's going to come in and you're going to, if you install that, it's going to install a whole bunch of services on your machine. And most of these services are to be able to do things. And so what we have here is we have the core here is distributed storage, and we have data nodes for that and so forth, so it moves around the data nodes. Then you have the distributed processing, which is actually the yarn and the Mapreduce. So that process will end up saying, okay, we have this job needs to be done. We need to coordinate the job across all these data nodes, and we have to say, okay, what if one of these fails? Can we recover? That kind of thing. Well, the Mapreduce, the service, the job tracking service and all that, is responsible for So the nice thing here is all this is set up so the plumbing is taken care of, which you're kind of used to. All right. There's metadata services, and so the metadata services is Hcatalog, and so one of the things you got to remember that this is not a relational database in the least, and so we have to be able to kind of put some kind of a structure on this unstructured data. And so the structure we put on the unstructured data is done through Hcatalog and Metadata Services. So you would end up putting in, the table, defining a table and the columns in the table and that kind of thing, right? So once you describe the metadata services that go in it, so this is actually reverse of what we do in a relational system, right? In a relational system, what do? You define the table, and then what do? Put data in. Here, what do? Yeah, we put the data in, then define whatever structure we want on top of it. So the structure can change, same data, structure can change, doesn't matter. You know what I mean? So it's a reverse process. So we pull the data in, we don't conform the data to the structure, we conform the structure to the data. All right. Now, one of the things here with metadata services is then we can start doing things like querying it. So we can take and use Hive, which is a query engine type thing, and it will convert those queries into a structure to retrieve the data using a query engine, query type engine, a lot like SQL Server. And then we have Pig. Has anybody heard of those Pig and Hive? So Pig, what do you program in Pig? Anybody program in Pig? No, it's Pig Latin. So one thing I like about open source is they have a sense of humor. So we write in Pig Latin, and so Pig Latin is going to be a scripting language. And so if you want to approach it from more of a scripting language type thing to work with your data, doing loops and that kind of thing, then you're going to use Pig. If you want to do set-based kind of programming, which you're used to in SQL Server, then you define it in Hive, and then it will convert that into a script-based language. So you have two options there. Now, the nice thing about the metadata services, remember, is that once we define it here, we can share them across. So you can use the same metadata in your Pig Latin or in your Hive HQL, and it's kind of nice that way. All right. And then we have workflow and scheduling. So you can actually schedule these and do workflows. That's Uzi. And then the management and monitoring services. There's Ambari and Zookeeper to do that. And then the data integration services are the Hcatalog APIs, which you can do there, and the web Hdfs to do that. And there's also, I don't think I have it up here, but there is you have the ability to move data between SQL Server and your Hadoop cluster and back and forth. Okay, so there's a service built in for that. Okay, so it all boils down to it as a person who wants to work with the data is Mapreduce. Okay, so Mapreduce Processing is a software framework for applications. And so what we want to do is we want to be able to process this vast amount of data in parallel, right? So the whole process here is in parallel, and you want to work on large clusters. Splits the input data set into independent chunks, which are processed by the map task. So the map task takes the data, and then it's going to set it up to start the process. Okay, so in the case we're going to see there, we're going to do the infamous word count type thing. And so with that, we're going to have the map process, which would be take the data in, and once the data is in there, it's going to end up, the first step would be what? So we have this, our word counting, so it's a stream of text coming in, and what's our first step going to be?
Break into woods.
Yeah. So it's like I said, the processing isn't hard. So what we're going to do in the word count function, we're just going to break it into independent words, right? And so then when we break it into independent words, that's the map process. And then what happens is this sorted, it sorts it and shuffles it. And so then it's going to send it into the reduce task. So the reduce task in this case is going to be what? Count words, right? So we're just going to count the word. So the sorted output is the master, the input for the reduce tasks. Framework takes care of scheduling tasks, monitoring, and re-executing the fail task, which is nice. So if it fails, process on one of these nodes, it can re-execute it, that kind of thing. So the Mapreduce framework and the Hdfs run on the same set of nodes, and so applications specify the input-output locations and supply the Mapreduce functions. Okay, so depending on the interfaces. And just to show you that in a kind of a pictorial background thing here, we have the clients, they send the job in, and then there's a resource manager, and so the resource manager is going to coordinate all the resources it needs, that needs to run the job, and then there's a node manager, so each of these processes that occur in parallel are going to be a node. There's a node manager there, and so there's also an application manager that is going to actually then orchestrate the processing of the application on it. And then there's a container inside there. All right. So all this is talking together and making this work, but it's all taken care of for you in the plumbing code, and you don't have to worry about the plumbing code, which is nice. So again, so here we have the semi-structured data, which is a log file. We just go to the mapping. So the mapping is going to end up pulling these out and into individual words. Okay, so each individual word here. And then get a count of that. And then it's going to shuffle and sort, and that's important. We know that when our reducer gets the input, that's all going to be sorted for us. All right? So we don't have to worry about unsorted data. In other words, this is the one reducer is not going to have to worry about unsorted data and maybe some of the other data going to a different reducer and so forth. It's going to shuffle it, sort it into it. So your reducer doesn't have to track all that kind of thing. All right, so this is where we're going to have to do a little bit of pretending. So we're going to run a Mapreduce job. So what do you do to once you set up the emulator, there's a couple things that would actually show up here. So one of the things that's going to show up is your name node, And so if I look at this, right now we have a look in. That's interesting. There. I lost it. Hold on. Well, I'll do it. So what we have here is, if you look at it, we're going to have a name node of this. So this is the Hdinsight emulator. There's a name node there. You can look at through this, browse the file system if you want. You can go ahead and look at the logs that are going to be there and so forth. So you can look at your nodes. So one of the things here is, because of the emulator, how many nodes do you get? One. Is it going to be very effective in Mapreduce jobs? No. So yeah, you wouldn't use that. In the real system, you would see like 8 nodes or 16 or 32, whatever. Okay, so you'd have a lot more nodes, but in the emulator, they only give you one. So that's just a way to get in there. Let me try and fix this. All right, so the other thing you're going to see in there is there's a job tracker, and this is the thing that's not working for me. So if you look, when you pull that up, it would actually tell you what's the running jobs and what are the jobs that are historic jobs and so forth. I should have got a couple screenshots and I could have faked it. So, but I'm all about this. Show you what's happening. So, and then we have this Hadoop command line. So using the Hadoop command line, you can go in there and work with the file system and work with your Hadoop. So in this particular case, what we'd end up doing is take a look at the and you guys see that? You want a little bigger than that? Or bigger? All right, so there's in the Hadoop, there's a file system command. So in this file system command, one of the things you would want to do there is you're going to, so the first thing we want to do when we run this map job is what? Mapreduce job. It's the first thing. Get the data in. So if we get the data in, we're going to have to bring it into the file system. So Hadoop file system, we have this make directory, and then it's a user, and then it's a pseudo directory system. So what I'm doing is I'm telling it to go to use a user demo1 and in. So it looks like it's user folder demo1 and then in. There's no folder structure on there. It's just that's the file name. But it's a good way for us to think about it. So that's what we're doing. Okay, so the user demo1 in, and then copy from local tells it to go ahead and copy this from the local file system into the Hadoop file system. Okay, so it's a totally different type of setup, file system setup. And so what that's going to do then is going to end up giving us the sample log is what I'm sending in. And then what's going to happen is the ls says list the file system, so we can go ahead and list the file system if we wanted to, and it'll give me all the all the folders in there, or the files in that particular path. And then this is the one right here, which is going to launch the Mapreduce job. Okay, so in the Mapreduce job, you'll notice we're using Hadoop and then jar. So what is jar? What's that? Yeah, well, you don't have to do that for it. It's just Java. I didn't even know that. So it's just it's a compiled Java thing. So we think of it as an assembly or something like that. So anyhow, you're going to have that. Inside there are a whole bunch of ones that are actually released with the Hdinsight emulator. So in this one, there's this Hadoop-examples.jar, and then we're going to send in the word count. So it's saying, okay, so run the word count code in there. And so with the word count, all you got to do is send it in what you want to send in. So the files that you want to send in this case, any log file that's in that input. And then where are you going to throw it out? Because it's going to process it and it's going to spit it back out, right? And so it's going to spit it back out into that out directory. And then if we take a look at this, we can do, this is just the file system, and then it's going to search through that particular file. So what happens is, when this sends it out, it's going to send it out as a text file, and it's going to name it as part, and this is for any job, so any Hadoop job that you send through, it's going to name the first text file part R0000, whatever. And then if it needs another text file, it's going to be 1, 2, 3, and so forth. All right. So you just have to know that, and you will overwrite your files if you don't move them somewhere else once you release it or once you run it. And so here we can do a find string trace. So we're going to look for trace, and then it would tell us how many it got, 450 or whatever. All right. So that is, and one of the things I wanted to show you here is there are some tools that are actually out there to kind of help you. And so one of these is Hdfs Explorer, and this is put out by Redgate. And so what I can do is I can go in here and set up a local host. Now hopefully I can get to it. I probably can't because I blew things up. There it is. And so we'll notice down here, and we have the user, demo1, input. So here's an example of the sample log files that went in there. And so just a sample going through. And then as it processes through it, it's going to bring it out. And notice here I have this success file, which is in a log, so it spits out some logs for me, telling me, how the job ran, and so forth. And then the actual part R00 is the output. And so you'll notice the output is just here. And then if you come down to the bottom, you'll see some of these. So we're going to have, for example, errors. There were 6. Fatal, there was 2, and so forth. Okay, so this went through and did a word count throughout there. So remember that, and I probably shouldn't, I didn't emphasize this enough. When we talk about the data going in and the data going out, what is the data going in and the data going out? Okay, well, first of all, it's a line of text. Okay, so it's a line-by-line input, but also it's key value pairs, right? So the key is going to be, in this particular case, the keys are the words, right? So these are my keys. And then the value is going to be the count. Okay, the value can be anything. The value can be a string, it can be an integer, it can be anything. Another file. Okay, so it's a key value pairs. Okay, and that's all you got to remember. So it goes in line by line, and then text line by line, and then we're going to split it into key value pairs, do whatever you want with it, and then spits it back out. All right, so that was using, remember, the built-in jar file that will actually do this. Okay, so now let's take a look at our streaming. Okay, so if we want to get away from using Java, write our own jar file. Oh, the other thing I want to mention to you is there are jar files out there that have implementations that you might need. So, somebody might have written let's say a file that does statistics, does a whole bunch of statistics on numbers. Just do a search on it, and more and more now you're seeing that somebody's released something, that does that. So you don't have to write these things in .NET if there's one already out there that does what you want. Just send it in, and then you just when you go in there, then you just like we did before, just say the jar file, the inputs, and then what you want out. Okay. I think you're going to see a lot more of these commercially as it comes along. So don't people not reinventing the wheel or whatever. So in this case, we're going to use Hadoop streaming. So it's a utility defined with the Hadoop distribution. And so use any executable or script that uses a standard in, standard out. So basically what that's saying is it takes text lines in, spits text lines out, right? And literally you can write those things in just about any language that you can think of. Okay, so a lot of them, you're going to see a lot of examples written in Python. Because Python seems to be the data scientist tool of choice from academia. So I'm seeing a lot of that. Runs on all data nodes. So remember, because of the fact that we're saying that this is going to distribute the files, the actual files, what has to happen here is if we're going to write this in C#, we have to have the framework on each node. Now, if you download it and do the Hdinsight emulator, no big deal, it's already there, right? Okay, but if you tried to run this in a setup, a server setup that wasn't already pre-configured for you, you'd have to know that that framework would have to be on there. And this is a problem if you're going to run it on Linux, because yeah, you have to try Mono, which I hear it works. So I've never tried it, but people are doing it. So I do want to try it on my sandbox, see if I can get something to work in there when I don't have to. Well, that's why I get in trouble, because I blow everything up. So, but anyhow, it's supposed to work, so we could use tomorrow. And then the mapper, just like I said before, the mapper is going to take and transform the input lines into key value pairs. The key and the value are separated by the tab character. Okay, so it's going to be a tab character, and then the value can be null. So the key can't be null, but the value can be null. And then key value pairs are emitted as lines of text output. And then the reducer, remember, is going to take those key value pairs as input that your mapper spit out, and then reduces a set of intermediate values which share a key, okay, to a smaller set of values. So, you know, you might be doing max, you know, get the max value or something like that. So instead of just counting, any aggregations you can think of, you can do, right? Now, it's probably going to end up that you're going to use this for things you can't do out of the box just using Piglatin or Hive or something like that, because, you know, use the tools for what they are. I mean, now we're playing around. We're in the playing around stage, so yeah, I can do the word count. No, I'm not going to do a word count for you know, do a Mapreduce on that. I do a Hive HQ knowledge.
Is it always limited to just text in now? For example, if we wanted to do statistics on JPEG images, that's something that would work with this system, or is it?
No.
It's all got to be text.
Yeah, it's text-based.
Okay.
The core is text-based. I'm not saying there isn't some add-in that somebody's doing. Like I said, that family of tool sets,
Yeah.
you might want to look into that, because there's, you know, there's stuff all over the place being tried and being put into this. So they could use the same processing or distributed processing on that type of a file, but they'd have to write a different program to process it.
Yeah.
So yeah, but so I'm not saying it's not out there. I'm saying the core is all about text in now.
Yeah.
So, but that's a good. I'll have to look into it too. That's true. Any other questions on it?
Is there any limit on the size of the key and value?
What's that?
Any limit on the size of the key and value?
Key value? Not that I know of. So, I mean, the keys can be, I guess, probably just kind of, you know, your own common sense type of thing where, you know, keys are going to be keys. That's what they're used for. So you want to be able to, you know, bucket things by the keys and all that. So my point would be the appropriate key. You want to pick the appropriate key so you don't bring the system down. But as far as a limit, I'm sure there is one, but I don't know what it is. You know, normally you're not going to run into one. It's not like six digits or something like that. So. Any other questions? And your values can be whole, you know, documents as far as that goes. So let's take a look at how you would write one of these. Okay, so I just have a okay, so I'm just gonna do keep it at this weird resolution. All right, so if I go. All right, so what I have here is just a .NET solution file, and has a two projects in it. It has a word count mapper program and a word count reducer program, and those are console type applications. So if I look at the mapper, the interesting thing here is that really there's nothing you have to do to go up and use Hadoop and Hdinsight, because it's just a scripting language or an executable that has standard in, standard out. Nothing else goes on inside here. So what we know is we're going to get an input. Okay, so we're going to do a stream reader, and the stream reader is going to accept the input R 0. And so then we're just going to say, okay, we're going to get a line in. The line is going to have a bunch of words. DevWeek is online. So I don't know if you guys knows that workshop. And then we're going to have the line by, while the line equals console.readLine is not equal to null. So we're going to go through and then just split those words. So line.split, split them by the space, you can split them by anything. And then we're going to write them out. So we're going to say word to lower. Okay, so I am doing to lower, and then I'm going to do a trim on the word. So anything you want to do in there really is to a text file or to a, So this is the mapper to set it up. All right. Questions on that? I can't get into. All right. So now the reducer is going to take in here those, again, it's going to take in a stream reader args, so it's passing those in. In this case, what it's actually passing in is key value pairs, right? So in that last, in the mapper, I just split the lines, and I didn't add the value. What would the value be for each word? 1. Okay, so, but it can also be null, so I just thought it was null, and knowing that if it comes in, it's going to be 1. So you could have written it either way. So to be more explicit, I would have said 1 for each one, but I didn't worry about it. So now if we come in here, we're just going to say, okay, we're going to come in, we're going to say, okay, the first word comes in. Okay, and then we're going to take a look at the next word that comes in and say, is it the same word? Is it the same word? Up it to 2. Okay, and then go through. Now, we don't even have to do anything crazy here because what do we know about the input? It's sort. Okay, so we didn't even have to worry about that. You know, creating a hash table and going in and out and all that. All right. So, again, that's about as easy as you can get it to get. So we wrote the mapper, we wrote the reducer. So how do you get all this to run? Well, if you go to look at this, we have a couple things we have to do there. So the first thing we're going to do is we're going to say, okay, copy from local, which we saw before. And so what are we copying from local there? What's that?
The compiled mapper?
Yeah, the mapper executable file. We have to copy that in, and then it has to be on the Hdfs file system because what's it going to do with that? Once you run the job, what's it going to do with that? It's going to put it on all the data nodes, right? So it's going to distribute it across all the data nodes. Okay. So we have to have it in there. The Hadoop and then the reducers there. So we're going to have that up there. And then this is actually not running it through the command line. This is actually running it through, and when you install this, you're going to get this Windows Azure PowerShell. Okay, so this is actually the way they're going to give a lot of their examples and so forth, and one of the ways they recommend you interact with it. The cool thing here is that you can interact with your emulator and you can interact with Windows Azure in the cloud the same way. You're going to just use the same scripts and everything. It's just how you run it, set it up. So if I look at what we're doing here, we're going to put in here I'm going to import some settings files. So in that setting file, the published settings, it's going to have my credentials for connecting to the Hdinsight. All right. So there's a file that you can import in there. You can download it from if you're doing it in the cloud, you just download it from the cloud. If you're doing it from here, it will actually mimic downloading it to some spot that you want. And then whatever the cluster name is. So my cluster name happens to be on my local host. And then we want to set up the mapper and the reducer. So we say what it is, the word count mapper, word count reducer. And then the mapper file and the reducer file are going to be tell it where those are because it has to distribute those out. And then the input folder, so that's where we're going to have all our input files, our output folder. And then where do you want to write the status of the job output? So it's going to actually spit out some text file and give you the status of the job as this is actually the meat of it here. So now what we're going to do is say, okay, I want a new Azure Hdinsight Streaming Mapreduce job definition. Give it the job name. And then we're going to say what the status folder is, what the mapper is, what the reducer is, the input path, and the output path. So you're defining all that, and so it's going to hook all that up for you, all the plumbing code for you, and then we're just going to run the job. So when you run the job, and then we'll wait timeout for 3,600 seconds. If it doesn't go, then it'll just time out. And so it'll go in and run the job and bring it back. Well, not bring back the results, but pump the results to the output. Bring back whether it's successful or not. All right. So the beauty here is the fact that you're only writing a small amount, a small piece of this. So you're writing you're actually writing the guts of what's going to be done to it, but all that plumbing is taken care of for you. So you line that up. It's actually pretty cool. And so you'll notice in the out here, I also have that part, and then if we take a look at the output on this, you'll notice here we have the key value pairs. And all those numbers kind of mean anything to me. But down here you're going to see the sample class 3 occurred 133 times. Notice the 4 occurred 1,349 times. There. Make sense? So the whole thing is pretty simple. So that's using the streaming and then using the job definition file to actually go in and run it that way on there. Now what if you wanted to make a application and have your application run the job, set up the job and run the job and everything, you don't want to do it interactively like that. So if we take a look at that, then we're looking at the option of using the .NET Sdk for Hadoop. And this actually shows some promise. Again, some of them have been released, some of them are still in works in progress. So just go out and see which one you want to play with. There's a Codeplex project, open source. So you have the mapper. So what they did is they wrote a mapper base class that you can use and inherit from, and it will set up. And it basically does the same thing. You have input key value pairs, does the same thing, and then transforms the input record into intermediate records. Use the reporter, so there's a reporter class that you can actually send out to report progress or set application status messages and so forth. And then there's a reducer. There's a reducer combiner class that is the base class that you're going to use for this. And it reduces a set of intermediate values and share a key to a smaller set of values. The phase shuffle, sort, and reduce is going to be the phases there. And then it outputs the key value pairs. So pretty much just a .NET base class to help you set these things up. Okay, so inside here you'll notice that you won't notice it. Okay, so what he did here is if you go in and you look at NuGet Packet Manager, you can actually go in and then end up going out and getting that .NET API for Hadoop. So it's a .NET MapReducer API, and it's part of the SDK up there. And then it also actually ends up putting a JSON framework down there too. And so just go ahead and get the latest version of those. And then what we have is we have the word count mapper first. So you're going to see it's going to look a lot like we've done before. In this particular case, we have you inherit from the base class, and then you have the using Microsoft Hadoop Mapreduce up here. And you'll notice what I'm doing in here is I'm going to say, okay, let's get a little more complicated, but that has nothing to do with, I just want to do something different. So as you notice, what's going to happen is it's going to send you the input line as a string. And then the mapper context is the context. And then what you're going to do is, in this particular case, I'm going to look for words in square brackets. And if it matches, I'm going to count that word. If it doesn't match, I don't want to count it. All right. So I'm going to emit that as context out of emit key value pair. And so you notice this, in this particular case, I'm actually including the value, which is 1 for every one of those. So this is for the mapper base. You get the context, so it makes it a little, I don't know if it makes it easier, but it's just more .NET-like.
Just going to use streaming underneath.
What's that?
So going to use streaming underneath.
Yes. Yeah, so it's just a .NET-ish way to write streaming. So, where it comes into play, I think, is when we look at the program and where I can launch the job from my own program. What you'll notice here then, that's just the mapper, and then the reducer. Come over to that. Here's my reducer class. You just inherit from the reducer combiner, And again, it's going to send in the key and the values. Okay, so we have here the key, and then we're going to have the values passed in here, and then the context. So in this particular case, all I'm doing is going to say context dot emit key value, and then the key that came in, and the values dot count dot string. So actually, this does make it a little easier because what did it do for all when it went through the shuffling and all that phase, sorting and shuffling. Anybody catch that? Anybody?
Well, it's turned into an IMU, so.
Yeah. So it actually, I don't have to loop through it. I can just do a count. You know, it's even easier. Something that was easy is now even easier. So I can do the count and just do two strings. So that's kind of nice. And now we have our word count job. So you'll notice a lot of the things that I was doing in that script file are just in the PowerShell are just going to be converted into here. So I'm going to have a word count, which job, and that's going to take the Hadoop job base. You just send in the mapper class and the reducer class, and then there's a configuration that you set up. And so basically the configuration is, in this particular case, is the input path folder and the output path folder, and then just return that back. One of the things here is that the inside here, this is going to default to your local instance, but you can also go ahead and do well, not in this particular one. I think it's over. Yeah, connect. So actually, here we're just setting up the input and the output. Over here, we're going to connect, and so this is Hadoop.connect. And in this particular case, we're going to end up looking at the connection. We can do one of three, and so we can use the URI cluster name, the string name, and the string password. Although this one's defaulting to my local host default stuff. So you can also do storage key account and all that. So if you were going to send this up to a Hdinsight job in the cloud, you would have to provide the URI for that, and the passwords and all that. So then it comes down through here, and you'll see the result, Hadoop.Mapreduce execute job. So we execute the job that we set up, and then it's just going to here end up putting out the exit code, so 0 is good and anything else is bad. And then in this particular case, I just wanted to show you some of the other things you can do in here with this SDK. You can actually manage the file system, and you can do a load, load from local and that kind of thing. So they put a lot of that management so you can actually add that inside your code here and run it, and then string the output or do whatever you want with the output that you want. Any questions on that? So again, it's going in the right direction. It's not all there yet, but it's getting there.
So you don't need to copy any executables to the server?
No, in this particular case, it takes care of that. It'll wrap up that class and send that in. And so under the scenes is actually doing the same thing, but in this case, the framework is actually doing it for you. And so when you provide it where your class is, it will actually compile it, wrap it up, and throw it. Good. so we actually kind of saw creating the Mapreduce job. So some other things that you can do there. So you can do things like submitting and running jobs. You can submit and run jobs that actually that you know, even if they aren't C# jobs, you can actually go ahead and run jobs that are held on there and so forth. So you want to do that. You can job pull, so you can look at the job and how it's going. You can retrieve your results back after the job. Like I said, there's a bunch of file system stuff you can do in there. So that's good. All right, so so the next thing then is a link. In the SDK, there's a link to Hive, which I think is worth mentioning. And so Hive query is using link, and even if you don't even know what Hive does or how it works, it doesn't matter because you're writing it in link, and then it converts it back to Hive for you. The link is compiled to Hive and then executed in the Hadoop cluster. Uses the web HCAT client connect to submit the job. So it's just you know, one of the standard interfaces into your to run a job on your cluster. And so HiveQL is similar to SQL. Link to ORM mapper allows queries in C# type querying. So I would recommend kind of fooling around with this a little bit. And so with that, you can do things like okay, so here's a application where I'm using that link to Hive, and so if I look at the packages in here, there's inside that SDK, there's that Microsoft link to Hive. That's all you have to really look up, and that'll show you where to get it, and also does the JSON thing too, brings it down. And then if we take a look at the first thing I'm doing is I have a Hive connection class. So in this Hive connection class, I have come in and put in the URI for that. Again, the username, password, storage account, these are all things that so if you're going to go up to the Hdinsight of the cloud, you would have to provide those. And so then what we need to do too is we have to say, okay, the structure that we're going to use to bring a results back. So one of the things it doesn't do is it doesn't automatically provide you with that structure. So you have to say, okay, I'm going to, what table am I going to get up there? Now remember, Hive is different than what we were just talking about, because Hive does, it takes those output files and put a table structure on top of it. So the whole process is do your Mapreduce, take raw file data in, spit it out into an output file, then you use Hcatalog to put a structure on top of your unstructured files, and then you can use Hive to query into those. So we're going one step above that to say we're going to do link to Hive to Hcatalog to unstructured data. Okay? So if we took it and take a look at that, and then I'm going to say, okay, we're going to have this table. I defined it there in Hcatalog, so it's log4j logs. And I know that it's going to have a Hive row. So each of the Hive rows, I'm going to define what the column name is. So here I got real lazy, it's T1 through T6. And then I have another one defined there too. But you basically go through the same thing. So you would define what the object structure is of your table that you have defined in Hcatalog. So once that's done, you can actually set up and go into the account. And so here we're going into a local account. And then you just do your basic Hive query from var q equals from logs in db demo logs 2. That was another table I had set up. And then when it brings it back, in this particular case, I'm just doing a count to string and throwing it out to the console. So this is a way you can use your application where you're already using link maybe to get into SQL Server or link to get into some other data structure. You can use the same structure to get into your Hive results. All right. Any questions on that?
How rich is the implementation of link?
The implementation is not too bad. It's not real rich yet. I think it will be. This is kind of just an incubator project, but I think it's worth looking into because I think it's going to develop into one of the main ways that we're going to get the data back into .NET applications. All right. So, take any questions that you have now, or any that you've been asking throughout the whole thing, so it's good.
I take it the files that you upload to Hadoop are distributed across the nodes. So, is that the case? If that is the case, what percentage of loss can it take if you lost, say, 50% of your nodes instantly? Would you definitely be screwed, for example? Or does it copy all the data to every node?
No, it doesn't copy all data to every node. So, I mean, 50% you'd probably be screwed.
Yeah.
You know what I mean? Just from my gut thing, I don't really.
When does it go
I haven't gotten into the admin side of this yet, but it's definitely fault tolerant. So it expects some jobs to fail just because of the distributed system. So that's definitely been hummed out. What I must say is the implementation of Hadoop is rock solid. It's been around for a while. The tools out there are rock solid and everything. The implementation of Hadoop on Windows is what's new. Okay, and that's actually, my gut feeling is that the Hadoop on Windows is running great. My problem is that the tool sets to get us to be productive are not quite there yet. So as a developer or as somebody who's going to manage other developers and say, well, we want the maximize your productivity, it's not there yet. You know what I mean? It's still in the dark ages of that. But as far as running large amounts of data through a system and doing analysis on large amounts of data, this is here to stay. It's a solid thing. The thing I'd like to see is actually some kind of implementation where I could run interact in C# on the Linux, leave it on the Linux server instead of bringing it over to Hdinsight in the cloud.
Still have the C# API, specifically with Mapreduce. Do you know, is that targeted towards Hdinsight, or could we expect that to run on other distributions? Because I'm using Cloudera and I've had terrible problems trying to get it to do anything.
Yeah, it works on. It should work on the cloud and local. There is HTTP for servers that was put out by Hortonworks. So if you want to do it on the premises, the problem with Microsoft right now is they're dissuading anybody from doing anything on the premises.
Yeah.
So
that's a big issue.
yeah.
You can't run stuff in the cloud.
Well, they don't quite understand that.
Yeah.
I mean, I don't know why, but they don't quite understand it. I always go to places and I say, how many of you are running your systems on clouds? Maybe 25%. So, I don't know. But you definitely want to get into the big data space if you have large amounts of data. I mean, you're doing stuff on here that there's no way you can do it on a SQL server. Maybe a PDW do that, but the expense-wise for that is pretty expensive. So. Any other questions? But I think the biggest thing to get out of here is it's not hard to do as far as doing your Mapreduce in C#, as far as that goes.
So I was just wondering, the Hive SQL HQL, does that actually let you write a Mapreduce in that language as well, or is it only for reading the data with the parsers?
Well, a little plug for my Mars talk is we'll talk a little about that, but and actually those demos still work. But anyhow, what it allows, the Hive HQL actually writes a Mapreduce job for you. So you write it. It's much like the query engine in SQL Server. Well, it's the same thing. It has a query engine. You write the Hive HQL. It actually interprets it down into a Mapreduce job, runs the Mapreduce job, gives you the results back.
And that's the link. That's part of the HQL.
Yeah, that goes into the that converts it to HQL, and then HQL converts it to Mapreduce and so forth. The other thing to remember that a lot of this stuff is, I mean, this is going to be niche stuff. So what we're saying is that you're not going to do this on, small amounts of data that you would load into a normal database and do your analysis on and so forth. This is huge amounts of data that you got to look through, and it really is good for aggregating huge amounts of data. It's good for looking up singletons in huge amounts of data. So if you said, okay, I want to look up, that's what I mean, look at, well, back home, government's getting in trouble because look up, this guy's cell phone records out of these huge amounts of data. So it's very good at that kind of thing. And I'm going to let you leave it. I'll plug here. So, if you want to get into this stuff, it's a good reference for you to have. There's others out there, probably not as good. And the last thing is, make sure you fill out the evaluations. There's a application online, if you haven't seen that. Everybody get that? It's on the back page of your handout if you want to bring it to. So that's it. So hopefully you learned something.